Good morning. Today we introduce a concept called polynomial division. Now, if you're following along in the notes on Teams, you'll notice that these notes are actually dated like January 16th, January 17th. Actually, the notes from the previous lesson were also dated January 16th because they were from different years. But I am going to split this lesson into three. We're going to do a day on polynomial long division. We will spend a day on something called synthetic division. And then we're going to spend a day on something called the remainder theorem. So we're going to take this one set of notes, and instead of trying to plow through it all in one day, which is what we would do on block scheduling, we're going to not just spread it out over 2 days, we're going to spread it out over 3 days. And I think in the long run, you'll appreciate that. Then we have a review day, and then we're ready for our first test of the third quarter. So polynomial long division. Most students don't like it. I was one of the few that did. There's two ways that you can divide polynomials. One is with this process called long division. The other is with a process called synthetic division, which we will cover in the next lesson. I always liked polynomial long division because it mimics very closely regular long division that you learned in elementary school. Now, this, like whether or not you gravitate to this method, really hinges on how well you are able to do long division. So I am going to review with you in detail a long division problem. And what we're trying to do with this is review the process, the steps. So we're going to do this problem. We are going to do 4,523 divided by 6. And of course, long division problems get way yuckier than that, but we want to keep it to where we're reviewing the process. All right. So here's what you do. This is your long division symbol. It should not have any hook on it. If you have a hook on it, it's a square root, okay? No hook. So if you're taking notes right now, which you should be, look at what you wrote down. And if you drew a square root symbol, I need you to get rid of the little hook on it. I don't fault you for doing it wrong. I've watched teachers do it wrong, but it is wrong, so don't do it. Now, under the division symbol, we put what I think is called the dividend. I think that's what it's called. Ms. McDonald and I were just talking the other day about how we don't consider this vocabulary particularly important. And then the divisor is the 6. At least I think that I got that right. And then the quotient, which is the important word, the answer goes up there. So when you are dividing, you go through what's called an algorithm. An algorithm is a set of steps that are guaranteed to get you at the right answer. And you don't even have to think, you don't have to make decisions, you just have to follow the steps. And so we go through this algorithm of like, what questions do I ask? And then what do I do once I have the answer? So here's how it goes. You look not at the rest of the number, you're only going to look at the 4. Okay, and you 5, 2, 3, we don't worry about. And you ask yourself, how many times does 6 go into 4? Or you could say, what do I multiply 6 by to get 4? Or to get as close to 4 as possible. And hopefully your answer is it doesn't. You can't fit 6 into 4. Now we move over and look at the 5. Okay, so once we've eliminated the 4, we look at the 5. And we repeat the same question. We ask ourselves, how many times does 6 go into 45? Now, I'm going to rephrase that. I'm going to rephrase it in an equivalent way that's going to be useful for when we do the polynomial long division. What do I multiply 6 by to get 45? Or get as close to 45 as possible? And I'll give you a moment to kind of think of your answer. What do you multiply 6 by to go as close to 45 as possible? You multiply by 7. Once you arrive at that, so you arrive at, okay, 7. 6 goes into 45, 7 complete times. You put the 7 over the 5. So there's a structure to how you line this up. So the 7 goes over the 5 because it was 45 that we were thinking of, okay? And this is the first part of your quotient. You write it in that column. Then you multiply the quotient by the divisor and you write the product underneath. So we're going to do 7 times 6, and then we write the product right underneath there. 7 times 6 is 42. And then we subtract. 5 minus 2 is 3. And then we bring down the next part. I'll let you think about that for a second. It's probably been a long time since you've done this. So you take your quotient, multiply it by the 6, write the product underneath, and then you subtract. And then you bring down the next part. And that's called one iteration of the algorithm. That's the whole algorithm. You ask yourself that question, what do I multiply by? And then you write the quotient up top, you multiply, write down the product, subtract, bring down the next part. And now we just repeat it, except now we're looking down here and we ask ourselves, what do I multiply 6 by to get as close to that 32 as I possibly can? Or how many times does 6 go into 32? And hopefully you're answering to yourself 5. And you write the 5 over the 2. So there's a structure to how you write this. And now we repeat the process. So we do 5 times 6 is 30, and the 30, the product gets written down below. And then we subtract. 2 minus 0 is 2, and then we bring down the next part. And we repeat it again. And it's long and it's tedious, and I know I can remember doing this in about 5th grade, like 4th or 5th grade, just doing some really nasty long division problems, but you get this like thought process down, you get this little algorithm down. So we ask ourselves again, what do I multiply 6 by to get as close to 23 as I possibly can? Well, 6 times 4 would be 24, that would be too much. It's like The Price is Right. Like you want to get there, get as close as possible without going over. So that we would go with a 3. Then we multiply. 3 times 6 is 18. Write the product down below and subtract. This time I have to do a little borrow carry and I get 5. Now there's 3 different options for what you can do with that 5 when you get to this point in the problem. One method, which is very common with students, is you just write remainder 5. You got 5 left over. When we were doing imaginary numbers and we were doing like the division by 4, like it was actually the remainder that we were looking for in the problem. So a popular thing to do is just say, okay, 6 goes into 4,523, 753 times with 5 left over. Another common thing to do is to go in like into that long division mode where you would do 0.0 and then you would bring down the 0 and you would keep going and you'd have the decimal point up here. And so you would keep going with the problem and you keep adding zeros until either you got to the end of the problem or you got to the required number of decimal places that your teacher asked you to get to. So maybe you had to go out 3 decimal places, so you had to divide out 4 times and then round with the last one. So those 2 you're probably familiar with. The last way is actually not as common, but you might have done it at some point. You actually take your remainder and you make it into a fraction with your divisor there. So you'd have 5/6. And so the answer would be 753 and 5/6. And you end up with this mixed number. This is the way that I want you to do it. I want you to do it with the fraction. Because that's what we're going to do with the polynomials. We're going to take whatever is left over at the end and put it over the divisor there. And like that's how we're going to express our answer. It's not how your book does, but I'm going to tell you not to go with what your book does. Okay, now this actually needs a little bit of practice before I show you what polynomial long division looks like. So I'm going to put a problem up here. I'm going to give you 346 divided by 5. And I just want you to divide that out using long division to get your quotient there, to practice the algorithm, practice the thought process. And we will pause the video and give you time to do that. And hopefully your work looks something like that, where you have 69 and 1/5. as your answer. And depending on when we're doing this, if you're watching this on your own, you obviously need to pause the video. If we're doing it in class, probably I already went over it. So that is to practice it. So what on earth does this have to do with polynomials? We are going to go through a process called polynomial long division, and it actually works the same way. So I am going to do out just one example. We're going to do one example and one practice, and then I'm probably going to just give you 1 or 2 homework problems that I want you to do this out with. And there's a reason for that. There's a reason why we're not going to do lots of examples. So the first and only example is 4x squared plus 23x minus 16, and we're going to divide that by x plus 5. And you could see it written like that. You could see it written with that other more traditional division symbol as well. So here's what we'll do. We'll set up the division the same way that we set up the division with the numbers. We take the 4x squared plus 23x minus 16 and put that on the inside, and then we put the x plus 5 on the outside. And here we go. Now, the thought process is, oh my word, I can't talk at all. The thought process is the same. So just like with the numbers, we didn't worry about the end of the number. We only really looked at that first digit or that first 2 digits. We're going to do the same thing. We're not going to worry about the 23x minus 16. The thing that's a little bit new with the polynomials is that we're also only going to look at the x. We're not going to worry about the 5. So pretty much with these 2 polynomials, we're going to only look at the leading term. So 4x squared and x. The question we ask ourselves is going to be the same question, except if I say how many times does x go into 4x squared, that's a really awkward question to ask. And so it's much more comfortable, and you'll see why I did it in the numbers problem, is I'm going to ask it this way. What do I multiply x by to get 4x squared? So you kind of do, this is like your brain here. This is your brain. So in your brain, you're saying, okay, x times something is going to give me 4x squared. And that would be 4x. If I did x times 4x, I would get 4x squared. So the answer to the question is 4x. Just like in this problem, the answer to the question was 7. And so just like with the numerical problem, I'm going to take my answer to the problem and I'm going to write it up here. If the answer to my problem was 4x, I'm going to write the 4x over the 23x. So just like with the numbers, there's a place that we write the quotient. You just don't write it wherever you want. Now the reason for that is when we're done, we want all the x's to line up. So like all the x squareds are going to line up, all the x's are going to line up, all the constants are going to line up. Everything is going to have this nice order to it. In this problem, once we had our quotient here, we did 7 times 6. So we took what was up here and we multiplied it by what was over here. And then we wrote the answer down below. I'm going to do the same thing here. We're going to do 4x times x, which will give us 4x squared. And now we're going to deal with the 5. So we're going to do 4x times 5, which gives us 20x. In this problem, once we had the product, then we subtracted. So we're going to do the same thing. We're going to subtract. 4x squared minus 4x squared is 0. And that should always happen because that's how we came up with the 4x in the first place. 23x minus 20x is 3x. And in this problem, once we had the 3, then we brought down the next part. So we brought down the 2. In this one, we're going to bring down the minus 16. And that completes one iteration of the process. Then we will repeat the process. And we go back to only looking at the first part and only looking at the x. And we ask ourselves, what do I multiply x by to get 3x? And so we have our brain. X times what gives you 3x? hopefully you said 3. And so if the answer is 3, it's positive 3, so we put a plus 3 up there. And then just like with the regular long division, we're going to take what we wrote, we're going to multiply it by this, and write the product down here. So once we had the 5, we did 5 times 6, wrote the product down here, and then subtracted. It's exactly the same algorithm. So 3 times x is 3x. 3 times 5 is 15. And then we subtract. The subtraction step is actually the step that causes the most problems for students, especially when you already have a negative, because if you subtract a negative, then it ends up being adding, and that actually ends up being the biggest hiccup in this process. 3x minus 3x is 0. Negative 16 minus 15 is negative 31. And there is nothing left to bring down, so we are done. And we're going to do the mixed number. So we are going to do plus negative 31 over x plus 5, which is what we did in this problem. We took our remainder and we put our remainder over it. Now, this we didn't need to do the plus because it was all numbers, and so we know what mixed numbers are. But with your polynomial, you have to do a plus. You could also do this. You could do 4x plus 3 minus 31 over x plus 5. So in this version, I did plus negative 31 over x plus 5 just to kind of make it a little bit more consistent with where I was putting the number part, but you could also just do a minus, and that is your answer to the problem. So there we go. I don't really expect students to enjoy this process because it's not enjoyable. But it is very, very much like your regular long division that you do with numbers. And so if you had an elementary school teacher that really drilled you on this process, you probably thought you were never going to have to see it again once you were allowed to use a calculator, but you do see it in this course. And so that thought process comes back up. So I'm going to give you guys a practice problem to do, and we may or may not do some small groups with this. I honestly don't know at the time of this recording. So the problem you're going to do is 3x to the third plus 2x squared plus x minus 4 divided by x minus 1. I will pause the video. This is going to take a bit of time for you to do, and then I'll go over it in the video, and we'll fast forward through the going over it in the video to get to the pros and cons of this process. Okay, now I think under other circumstances, I might just do the problem out and be like, oh, here are the answers. But for those of you that are rewatching the video, or you're watching it at home for the first time, or I don't know, just anybody on the internet that finds this video, this is worth me just talking through the steps again. So we're looking at just the x and just the x, 3x to the third to start off with. And I ask myself, what do I multiply x by to get 3x to the third? And the answer is 3x squared. So I put the 3x squared here so that all of my x squareds line up. Then I take 3x squared and I multiply it by the x minus 1. So I get 3x to the third minus 3x squared. Because 3x squared times x is 3x to the third. 3x squared times negative 1 is negative 3x squared. Now we subtract. But this is where it gets a little dicey, because here I'll put the subtraction sign in, but this is already being subtracted. So if you subtract a negative, it ends up being adding. And this is really beneficial to be able to see the color so that you can see, I just didn't put a plus sign there, it was a minus sign and became positive when I went to do the subtraction. 3x to the third minus 3x to the third is 0. 2x squared, and now it becomes a plus 3x squared is 5x squared. And I bring down the next part, which is plus x. And now we repeat the process. What do I multiply x by to get 5x squared? The answer is 5x. 5x times x is 5x squared. And 5x times negative 1 is negative 5x. And now we subtract. You subtract the 5x squared, but on this one, it's already negative. So when you go to subtract a negative, it becomes adding. 5x squared minus 5x squared is 0, and x plus 5x is 6x. And now we bring down the minus 4, and we repeat the process again. What do I multiply x by to get 6x? I multiply by 6. 6 times x is 6x. And 6 times negative 1 is negative 6. And now I subtract 6x minus 6x, and then of course this is already negative, so when I go to subtract a negative, it becomes adding. 6x minus 6x is 0, negative 4 plus 6 is 2, and so I will have plus 2 over x minus 1. And this is, oh, I can't see what I'm doing. There we go. That is the answer. So that is a fun-ish process. Let's talk a little bit about what this is and what it does and why this is worth doing. What are the pros to this method? The biggest pro is that it always works. And next class, I'm going to show you an alternative way of doing division, which is much, much faster. Students vastly prefer it. I did not like it as much, but what do I know? But the other method does not always work. And this method, this thought process will always work for all types of polynomial division problems in the entire universe. The other big advantage to this is that it resembles what you already know how to do. And that's a really big pro. Provided you do know long division. Now, if you don't know your long division with numbers, then that is not a pro, and then you probably hate this even more. But for those of you that know your long division pretty well, this is actually a huge advantage. And I think this is why I liked it, because the process made sense to me. The process clicks with what I already know how to do. And even if I forget like other stuff, long division is so ingrained in my brain at this point that I can figure out my polynomial long division even if I haven't done it in a while. But that is not to say that this method does not have its cons. One of the biggest cons is that it is a long process. It is something that takes a lot of time. There's a lot of steps. Anytime you have something that is a long problem, that makes it error prone, because there's just so many pieces of the problem. You've got to come up with this number, then you've got to do multiplication, and you got to do subtraction. There's just a lot of places where if you drop off one exponent or you get a plus confused with a minus, like it doesn't take much, and then now the entire problem is wrong and you're lost in a quagmire. So anytime a problem is long, it's going to be error prone. The other big disadvantage is that this takes up a lot of space. The physical amount of space that this problem takes up is pretty daunting. And so just, it's just not an efficient way. Now, so it always works. And I said there's an alternative way that you can do these problems that I will show you in the next class called synthetic division. The big con to synthetic division is that it doesn't work all the time. But the reality is that it's going to work almost all the time when you're going to want to or not want to do polynomial division. But when you have to do polynomial division, synthetic division will work. But because it doesn't always work, I have to show you this method also. I have to kind of go through this process with you so that you know that there's a way that will work all the time. So your homework is just going to be 1 or 2 problems to carry out this process. And then we will introduce the alternative way next class.